Came in like a wrecking ball. 4.4 SSS and SAS. Today we're going to continue with triangles. Again, this whole chapter is about triangles, but now we're going to look closer into some relationships between two triangles. The SSS and the SAS are acronyms for theorems, so I'll tell you about them in just a second. Here's the first one. SSS stands for side, side, side postulate. A postulate, again, if you remember from chapter 1 vocabulary, a postulate is just a mathematical rule that is accepted without needing any proofs. All right, so the postulate says this. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. And so it might sound obvious to some of you guys. It might sound confusing the way it is worded, but all it means is if you have two triangles and you match up all three sides, you have to have all three sides that match up. So if all three sides match up, then these two triangles are congruent. Okay, that's all it says. So here's an example. Notice I have two triangles and I push them together to make kind of like a parallelogram. But if you think about them separately, are these two triangles congruent or not? If they are congruent, you have to show that there are three sides that are marked. Here we have one side. Here we have another side. So we got two pairs of sides, but the postulate said we needed three pairs. And it turns out that even though the third side is not marked, they share it. So if they share the third side, you are allowed to mark it in there for them. And so they do share the third side. So these two triangles are congruent because all three sides match up. Here's another example. Two triangles. Do all three sides match up? Here I see one side match up. They kind of share this side, but they don't really share it because one side is shorter than the other. So you cannot mark it if they're not exact. And then nothing else is marked. And so this is not congruent. Not congruent. Only one side, and that is not good enough. Let's do a little proof. All right, proofs are, again, you have to show all your steps to get to what they want. So they want you to show that triangle DAB is equal to triangle BCD. So they want you to show that the top triangle is congruent to the bottom triangle. So how do we show something is congruent? We show that all three sides are equal. All right, so first thing, it said, and then remember with proofs, there are certain things you just have to just do. The first step is always the given. The reason is the given. It says side AB is equal to side CD. So they tell you that, so you're allowed to mark it. It also tells you that AD is equal to CB. So you're allowed to mark it when they give it to you. All right, so we got two pairs of sides. Well, what about that third side? The one that they share, the middle one, BD is equal to BD. Now, do you guys remember what that property was when you just repeat itself? Like BD is equal to BD or X is equal to X. It's kind of one that you should remember. And if you don't, that's fine. Remember it from now on. When you just say something is equal to itself, that is called the reflexive property. All right, so the side they share is equal to each other. All right, so then we have shown that the triangle DAB is equal to triangle BCD, and the reason is because we just showed that all three sides match up, side, side, side. Side, side, side theorem, postulate. Let's do another postulate. This one is SAS, side, angle, side. So it turns out you really don't need all three sides. If you don't have all three sides, we can use another property. You can use side, angle, side. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So all of that just means, what if we don't have all three sides? What if we only have two sides? Well, if you only have two sides, then you also must need an angle. And not just any angle, it's included, which means it's in between the two sides. So that angle has to be in between the two sides for the two triangles to be congruent. Okay? Let's do an example. Are these two triangles congruent or not? Let's see. We have one side marked. Good. We have another side marked. Good. So that's two sides. The third side is not marked, but it turns out that we do have these angles, vertical angles. Whenever you have vertical angles, you're allowed to mark them as well, because we know vertical angles are congruent all the time. All right, and so it looks like we do have a side, an angle, and a side. So yes, these two triangles are congruent. Let's see, how about this one? This one has a side, and even though the angles are drawn differently, one arc and one arc means that they are equal. So yes, that angle is good. So we got a side, we got an angle. Nothing else is marked, but if you notice, this side they share. It is reflexive, so we do have another side. Unfortunately, this is not side, angle, side. And the reason why it's not side, angle, side is because the angle, let's see, I'll draw these in again. These angles are not in between the two sides. All right, it actually spells a bad word. It's angle, side, side, which is a bad word, which is no good. We cannot have the angle outside. We need the angle in between the two sides. So we needed, basically we needed this angle and this angle. That would have given us side, angle, side. So they gave us the wrong angle. So this one's not congruent. All right, that's a little bit tricky. Let's do another proof. This one's slightly bit longer. All right, so it says that C is the midpoint of AE and C is the midpoint of BD. You have to show that those two triangles are equal, congruent. All right, so in order to show that two triangles are congruent, you have to show side, 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 or side, angle, side. So one of those two. All right, so right now, we always start with the given. C is the midpoint of AE, given. Notice I only wrote one of the givens down. I didn't write them both. All right? I don't have to write them both, even though most of the time you just write everything. But I'll show you why in a little bit. And if you write it at the beginning, both of them, that's fine too. I won't mark you wrong. But okay, so C is the midpoint of AE. So C, ooh, that looks ugly. C is the midpoint of AE. Now, if you know what midpoint means, you should know that if something is the midpoint in the middle, when it's in the middle, that means it cuts something in half. It means this. AC, that piece, is equal to EC, the bottom piece. So midpoint means you cut it in half. So AC is equal to EC, definition of midpoint. So when something's a midpoint, you get two equal pieces. Next one, C is the midpoint of BD. Notice that's the other given. Oh, I didn't write it in. Or maybe I did, but the PowerPoint is out of order. That's the other given. I didn't put it at the very top. I decided to squeeze it somewhere in the middle. And that's fine because now I can talk about this one. C is the midpoint of BD, which now means it cuts this piece in half. Oh, there it is. Definition of midpoint again. All right, so we got two pairs of sides. What else do we have? I think you might know. I think this angle might be equal to this angle. Now, most of you guys might say angle C is equal to angle C. Remember, that's not good enough. We want to use three letters. Angle DCE is equal to angle BCA. All right, use three letters to be more specific. And what are those called? They are vertical angles. Okay, so it looks like we have enough information to show that triangle ABC is congruent to triangle EDC, and that is because we were able to show side, angle, side in the correct order. All right, one more slide to go. This last one's kind of easy. It's asking you what's missing. Label the picture to show side, angle, side. All right, so right now we have one angle and one side. We have one angle and one side. We need one more side to be marked. What side are you going to mark to make it side, angle, side? This one with this one. So you can either mark it or you can just say MK needs to be equal to RP. Oop, RP. All right, so this last part is just finding what missing piece is needed to show the two triangles are congruent. All right, now this is the first time we've done something that was kind of weird with this whole proving two things are equal using some rules. Let me know in class if you have any questions, but otherwise go ahead and start the homework.